differences in the different file formats. So JPEG is probably one of the most popular file formats. That last picture I showed you is a JPEG. This is JPEG. JPEG is really good for images with a lot of color and a lot of variety. You can see this picture. It's not really pixelated. There isn't a lot of compression artifacts, and it's sizing well, even though this is zoomed in a little bit. Same thing down here for pings. You'll notice that the color is a little bit brighter. Pings actually have more colors than JPEG does, and it does the same sort of good job with not having artifacts and having lots of colors and dealing with the there's not a lot of hard edges here. It's kind of fuzzy, but then when there are hard edges, they show up well as well. Now GIF, on the other hand, is a format that's terrible for images. You can see that it's not got a lot of colors. It sort of, you get this effect of the colors breaking into like hard lines, and the hard edges get broken up into weird little color artifacts. And you can fix that a little bit with some options that GIF has. There's something called dithering. So this is the same image as a GIF with full dither, and it breaks up some of those lines so you don't have those lines in here and here, for example. They're broken up so it looks a little bit smoother, but then you can see these dots as well. And I've actually saved these images to emphasize the effect a little bit. So for example, this would be a dither with the full color, and you can see it's a lot better than this one, but it's still not as good as the JPEG or the PNG images. This is the best image that you can create with the GIF. Compare it to the JPEG below. You can kind of see some of the differences. So those are the most common file formats for images on the internet. It used to be that PNGs weren't well supported by browsers, but nowadays pretty much any browser that you're going to be using will support PNGs. Now also take into consideration the compression, because all these are actually compressing the file. This full color GIF is 72 kilobytes compared to 40 for the dithered one and 39 for the normal one. Now the PNG has a lot higher of a file size because it's using the full colors. But if you wanted to, you could use the same number of colors as JPEG or GIF, and the PNG would actually be better compression. So PNG is sort of a better file format all around for a lot of things. And then the GIF 47. GIF is very popular because if you take a picture on, say, a digital camera, it's usually going to always automatically save it in the JPEG format, and it has good compression. You can set the compression values to be little compression, which will make the file size much larger, but it'll look better, to a lot of compression, which can make it smaller if you're really worried about bandwidth. Now this last image here is the JPEG in its original size that is not, it's not compressed, it's not resized down, it's just the original JPEG compression. And I've browser resized it to be a lot smaller. So if we look at the picture unsized, it's this big. So this is something that you'll see on some websites where the original picture hasn't been sized down for the web page. It's just right there and then sized down using the browser. And that slows down the browser when you're trying to load and scroll, and it slows down the downloading speed. And you can actually see in here, if you have an eye for it, there's a lot of artifacts from browser resizing, especially since this is actually sized up so it's closer to the original size. If I were to make this the original size that it's sized down to, you can see a lot more artifacts in here. So don't ever depend on just the browser to resize an image. It's almost never going to have the same quality, and it's going to have it's just going to be a negative effect on the usability. So I'm going to go in here. I'm actually going to delete that one because it's slowing down everything. So now we can look at the effects, the way that these different image formats deal with more precise lines and fewer colors. So this would be the sort of images that you might see that aren't just photographs, but say an image that is part of the design of a website. So borders around things, or you know, little logos or decorations that you want to be precise. JPEG does not do a good job with these sort of images. You can see here this these artifacts of the compression around the edges here. It does a little better job on the straight line, although the corners you can see a little bit of artifacts. And this is, even if you have it at really high quality, you're always going to have a little bit of this artifact. And also, the coloring is not as good. You can compare it to the ping. This red circle here has lost a lot of its brightness, so is the blue square. JPEG is not a good format for these sort of images. Ping does well at both. It's both good for photographs and for this sort of line art with more precision needed. Even though it's a compressed image, there's not as much loss in here. In fact, I can't see any loss. Every pixel looks like it's in the correct place as far as I can tell. And it's also much smaller. This is an 8 kilobyte image, and the ping, which has superior image quality, is only 4 kilobytes. And this is also something that GIFs are really good at. This is a 4 kilobyte GIF, the same size, and it's pretty much indistinguishable from the ping. They both display it really well. So some other differences that you have are GIFs have been able to do image transparency and animation. And pings can do transparency as well, and there are some methods being employed to make pings use animation as well, but it's not well supported at this time. So right now, if you have an image that you want animated, it's going to be a GIF usually. If you want a photograph, it's going to be either a ping or a JPEG. So here's an animated GIF. The browser's crashing a little bit because it's a fairly large image and it's resized. So this is a GIF that's just continually repeating. And you could do the same thing with ping, but it's not as well supported. What pings are really great at is alpha transparency. So this image right here has this white area is not just a color placed on it, it's actually a transparency. You're seeing the white background behind this image showing through. And you'll notice there's a gradient, it fades slowly. When a GIF does transparency, it's just a one color transparency usually, which means I could select maybe the red color and make that transparent so that all this would be transparent. Or I could select maybe just the white color, but you couldn't do something like this where it fades out. In fact, I'm going to pull open Opera browser, because the Opera browser has a built-in extension, sort of like Firebug in Firefox, that'll allow me to take this up. So I'm highlighting it right here. Now I'm going to pull the margin up, make it negative, and you can see that it's actually transparent all the way throughout the whole range. It's not just a single color. So that's alpha transparency, and it has some problems with Internet Explorer, although you can add in some special code to make alpha transparency work in Internet Explorer. I think Internet Explorer 9 will support alpha transparency and pings. All other browsers will support it if you have a modern version. So that is the images